So this is a classified paper 4 question related to topic waves, the block 3. So we'll start with page 35. Page 34 and 35. Page 34, figure 7.1 shows a box ABCD, as you can see the outline of the box. Uh, the box contains two identical glass prisms. The two prisms are placed in the box. One of which is shown the light incident on prism 1 and undergoes a total internal reflection. Total internal reflection means when the light reflected back in the same dense medium, like example, a light is moving from water to air, so light should move out from water to air. But if the light reflected back in a same dense medium, we call that as a total internal reflection. On a figure, complete the path of a ray of a light through prism 1, and then on a figure 7.2 draw the second prism inside the dashed square so that the light reflected inside the glass and emerges from the box as shown to complete the path. So we have first one of the prism is already drawn. We have to complete the path. First, when the light is moving, it is passing here, it is passing along the normal. So whenever the light is passing along the normal, it won't change the direction, it will go straight. Whenever light is passing along the normal, the speed will change, but there's no change in direction. Normal means when it is perpendicular to the surface, we call normal. Okay. Then the light will undergo a total reflection because light should go out. If a simple refraction happen, the light will move from glass to air. But if it is angle of incidence was equals to the critical angle, the light will travel along the surface or angle of refraction will be 90. But the angle of incidence is more than the critical angle. So as a result, the light will reflect. When it reflects, this light will go straight, pass straight out. Then it has to strike another prism and then it goes out, emerge out in this way. So we have to draw another prism. So the same way we have to draw another prism. So when the light, it does not change the direction. So the prism, it means it is passing along the normal here. This is what happened. When the light, first thing, when it passes here, enter the prism perpendicular to the surface, it's passing along the normal, it will pass straight. But then here, the angle of the incidence is more than critical, so light will reflect back. Here, again, it passes straight because passing along the normal, when it strikes, the angle of incidence is more than critical, so light will reflect back. So that's how a periscope, maybe you have seen a periscope works, that if you want to see above the wall or in a submarine, so these periscopes are used, which use the same concept of the total internal reflection. Is it clear? The drawing? The next we have select the statement that correctly describe the necessary conditions for a light to undergo a total internal reflection. When a light undergo a total internal reflection, the angle of the incidence should be greater than the critical and the light should move in a dense medium. So the angle of the incidence, we have to take the angle of the incidence in the glass is less than the critical. No. The angle of the incidence in the glass is greater than the critical for a light in the glass. That's right. The angle of a reflection in a glass is equals to angle of reflection and refraction are equal. No. The speed of a light in a glass is greater than speed of a light in air. No. Light travels faster in air as compared to that of glass. The speed of a light in a glass is equal. The speed of a light in a glass is less than the speed of a light in air because light travels fastest in vacuum followed by gas, and then gas is faster than liquid and a liquid faster than a solid. So these are the two boxes which we have to tick. The next is a wave passes through a gap in a barrier and the wavelength is same as the magnitude as the width of the gap in the barrier. Tick one box to indicate what happened. Whenever a light is passing through a gap, does it diffract? Whenever a wave is passing through, does it diffract and disperse? No. What will happen? It will diffract. Because when the wave is passing through a gap in a barrier, as it has a wavelength is approximately equals to width, so the light will diffract. Diffraction means like spreading of the wave when it passes through the gap. Here we have to complete the path on a figure. Draw a wave front to show in a shallow water. So in a deep, the wave travel faster. In a shallow, it travel slower. So if I want to complete the wave front, like if it was traveling at the same speed, then I should draw like this. But because in a shallow, it is traveling slower compared to that of deep. So what I should do, I should draw lag behind. Like if it was traveling at the same speed, I will draw like this. But because it slowed down, so it will lag behind. We'll draw in this manner. And whenever the wave travels from deep to shallow, what will happen? The wavelength will decrease. The speed will also decrease, but the frequency remain unchanged. And what is the direction in which it travel? The direction of the wave is always 90 degrees to the direction of the wave front. So this will be the direction of the refracted wave. The depth of the shallow water is now changed so that the speed of a wave in a shallow water is 0.6. The speed of a wave in a deep water is 0.4. The distance between the successive wavefront in a deep water is 1.4. Calculate the wavelength in a shallow. As we know, the frequency never changes. Even it's in a deep or in a shallow, the frequency never changes. And what is the formula for a frequency? Frequency is a ratio between speed and wavelength. The ratio of a speed and wavelength is called frequency. So it means the frequency in a deep water will be equals to frequency in the shallow water. Because even the water travel from one medium to another, but the frequency never changes. So frequency is actually a ratio between the speed and the wavelength. So speed divided by wavelength in a deep water will be equals to speed divided by wavelength in a shallow water. Now we just substitute the values. As I mentioned, the depth of a shallow water is now changed. The speed of a wave in a shallow is 0.6. So this is 0.6. We can say this is V1, lambda 1, V2, lambda 2. Now we just have to substitute. The speed is 0.6. The speed of a wave in a deep water is 0.8. The distance between the successive wavefront in a deep water is 1.4. We need the wavelength in a shallow water. So if we need x, so we just cross multiply. So this will be 0.6 times 1.4 because we just cross multiply it. This will be multiplied here, x will be multiplied with it. So 0.6 times 1.4 divided by 0.8. What's the answer here? We'll get the answer in centimeter because we did not convert the unit. What's the answer? So 1.05 centimeter. And it is obvious because in a shallow water, the wavelength should decrease. Like in a deep water, if it was 1.4, in a shallow, it should be less than 1.4. Is it clear discussion? Any doubt in this?